What is up, ladies and gentlemen? This is going to be a video walkthrough of the exam prep problem round down. So the problem reads that we're given some power of 2, and we're given a positive number num. And what we want to do is round num down to the nearest multiple of power of 2. So we can assume that power of 2 is greater than or equal to 1, and we are only allowed to use bit operations and one subtraction/addition operation, right? So I think it's helpful. Let's first kind of walk through the examples, then let's try to build up the intuition for the solution, and then let's turn it into code. So looking at these examples here, in each one of these examples, we have two numbers, right? The first one is our power of 2, and our second one is going to be our number, right? The one that we're actually rounding down. So if we're considering this first example, if we're given 53 as our number, and we're trying to round down 53 to a multiple of 8, to a multiple of 8, we know that like the multiples of 8 go 8, 16, 24, 32, 40, 48, and 54. So the nearest multiple of 53 is going to be 48. That way we can round 53 down to, right? So that's why the answer to this one is 48. And maybe let's walk through one more example just so we can kind of see this intuition again. If we're considering this next example, where we have 90 rounded down to a multiple of 16, well, we know that 16 times 5 gives us 80, and 16 times 6 gives us 96. So we can see that 80 is the nearest multiple of 16 that we can round 90 down to, right? So kind of now that we understand what the problem is asking, let's transition into maybe approaching the logic for the solution, right? So what I'm going to do now is I'm going to try to write these numbers in binary and see if we can maybe learn something about how these powers of 2 look and how 48 looks in comparison to 8 and 53, okay? So suppose that we have 53 in binary. And let's also put 8 in binary. Okay, so for any number in binary, we're going to have like bits in these spots. We're going to have like a bit in like the 1 spot, the 2 spot, the 4 spot, the 8 spot, the 16, 32, and let's just stop at 64. Okay, 1, 2, 4. Okay, and then the same will go for 8. So if we're considering 53, you know that 53 doesn't have anything in the 64 spot, has a 1 in the 32, a 1 in the 16, right? That puts us at 48 total. And then we can skip. So it means that we have 5, like 5 left to account for. So we could 0, 1, 0, 1. So that's like the binary representation of 53. If we're looking at 8, we'll notice that 8 just has a 1 at the 8th bit spot, right? So I think the next thing here is let's consider maybe our answer, which is 48, right? And I purposely copied 53 so we could see how it's kind of similar to 53. So this is a round down operation here that we're kind of considering. So if we're looking at the round down operation, the only way that 48 differs from 53 is that these two bits are kind of zeroed out, right? So I think it's important to highlight that these are the only bits that differ between 53 and 48, right? And one thing to kind of notice here is that both of these bits occur after our power of 2, right? or maybe to the right of our power of 2, occur the bits that we zero out, right? And all the bits maybe to the left of this power of 2, right, like 32 and 16 and 64, we kind of keep as is, okay? So maybe kind of writing that realization more formally, the bits to the right of the power of 2 in 53, we zero out the other bits stay the same. So maybe just like an example where this happened to be the case. So let's maybe dig a bit deeper and see why is this the case, right? So if we're considering 53, you can kind of notice that 53 is equal to 1 plus 4 plus 16 plus 32, right? So if we're kind of considering this sum here, notice that, actually I'm going to rewrite the sum in the opposite order. It's equal to 32 plus 16 plus 4 plus 1. So looking at the sum, notice that these bits here are smaller than 8, right? These numbers to the left are bigger than 8, right? And what's important here to notice, here's like the main takeaway, is that all of these numbers in red that occur to the left of 8 are multiples of 8, right? So notice that 16, 32, 64 are all multiples of 8. Like, on the other hand, if we're kind of considering 4, 2, and 1 aren't multiples of 8, right? So if we're trying to take some number like 53 and we want to round it down to a multiple of 8, all we need to do is just keep the bits at these red spots, right? So if we're looking at 53, notice that 64, 32, and 16 are all multiples of 8, in addition to 8 itself, right? So we can maybe include this 8 here, right? But when we're considering the numbers or the bit spots smaller than 8, like 4, 2, and 1, any number that has a 1 at a 4, 2, or 1 position isn't going to be a multiple of 8, right? By having a 1 at any of these spots, we know for a fact that that number isn't a multiple of 8. So all we need to do in order to take any number and round it down to a multiple of 8 is we look at all the bits of positions that are smaller than 8, like 4, 2, and 1, and we just zero those out, okay? So that's like the main idea here, is that we just need to zero out the bits for the positions that are smaller than 8. In order to do that, what we need to do is maybe create some sort of mask that we can then use to extract the bits of 53 that we want, right? So kind of the intuition here is that we want to keep all of these bits the same, right? And we want all of the green bits to be zeroed out, right? We want all of these to get zeroed out. So if we're considering that we want to do some sort of operation to 53 in order to keep these bits the same, and we want these bits to go to 0, my intuition is we want to use an AND operation. Right? We want to do an AND operation where all of these bits are 1, because if we AND a number with 1, it stays the same, right? And all of these bits are 0, because if we AND a number with 0, it gets set to 0. Okay? So now that we kind of know that this pink thing is our mask, and all we need to do in order to like round 53 down to a multiple of 8 is AND, oops, let me go to this. All we need to do to round 53 to a multiple of 8, which is 48, is AND it with this mask. So the next kind of question is, how do we create this mask, right? Well, what we're given is this number 40, this number 8. So somehow, given this number 8, we need to do some sort of bit operations to produce this mask, right? So if you're looking at the number 8, if we're looking at 8, it's 0, 0, 0. I don't like this pink color. Okay, so looking at 8, it's 0, 0, 0, 1, 0, 0, 0, right? And eventually, after doing some sort of operations, we want it to look like 1, 1, 1, 1, 0, 0, 0. Okay? So this seems like a little tricky, but one thing to kind of notice is that if I'm looking at the number 7, it's 0, 0, 0, 0, and then we have 1s in all of these spots, right? So what we can kind of see is that going from 7 to this number is really easy, because all I have to do is just flip the bits of 7, right? If I flip all of the bits of 7, notice that we get the mask that we want. So kind of putting it together, if I take 8, I subtract 1, it gives me 7. Then I flip all of these bits, then it gives me my mask, right? So that, in essence, is our solution, is that we take the power of 2, which in this case was 8, we subtract 1, that gives us, in our example, the number 7. Then we want to flip all of those bits. So I'm going to put the flipping bit symbol. And now that I have my mask, what I want to do is I want to AND my original number with my mask to get my rounded down number, right? So that ANDed with my mask, or ANDed with the original number, gives us our answer, okay? So yeah, thanks for watching this video walkthrough. I hope you all found it helpful.